Shake Table Lab by Richard Lovely and Michael Chewy. Before we even started to build our building, we drew out a blueprint of how we wanted our tower to look. This is the outcome that I drew. Here is a time-lapse video of Chewy and my first day of building. These two videos show the second chunk of the building process. Here is the third area of our building process. Here is our final video of our building process and the outcome of our building. Here is a construction sketch showing the first and second floor 18 centimeters high, first and second floor 10 centimeters wide. A total height of our building is 37.5 centimeters because the roof added 1.5 already to our 36 tall building, including the 2 stories. After building, we static tested our building. We put 2 sandbags on each floor, 4 in total, and saw if our building was strong enough. We used tape to strengthen our building, and we also doubled up the straws to make our support stronger. Our support is the strongest area on our building. It will help the building last longer in our Shake Table Lab earthquake simulator. We found out soon in the Shake Table Lab that our crossbars were the weakest parts of our building. This caused our building to fall at a very early stage. Our tape isn't as neat as it should be because it's mostly rat's nest, but it still keeps the straws in place and in check. The extra supply that we got was construction paper to help and complete our flooring so that our sandbags would have a nice structure to stay on while the shake table was happening. Here it is, the video of our tower falling. It's sad, but it had to happen.
Whoa.
Or a 10.
We say that for when they get.
Fast 12.
Alright, so that's 5 and 5.
So we have an 8?
We're ready for 6 and 6. This will be 100.
If you get this, you have 100.
I predict more difficult shaking coming.
Yeah, I do.
So I'll take it.
Guys, your bottom floor. Guys, your bottom floor.
Ian, it's gonna break here. It's gonna break.
Their bottom floor is very.
This is light.
It's already flexing. It's already flexing in the back.
Oh, it's already flexing. Okay, at least Richard, Armani, you gotta be now.
Guys, it's flexing in the back. It's flexing so badly.
Here is the XYZ graph. X stands for side-to-side motion, the Y stands for the forward and back motion, and the Z stands for the up and down motion that was going on in our building during the shaking. Here is one of the interviews that Chewy shot of me answering the 5 questions that Mr. C gave us. Hi, I'm Richard Lovely and I'll be talking about my Shake Table Lab. Our building supported 10 sandbags. Our building mostly failed at the back cross beams and at the sides because on the second shake with only 4 sandbags, it started to already flex. And that really paid that we didn't spend enough time on our crossbars as we thought we did. If I could make a change, I would have probably maybe, if we had a little bit more straws, we could have maybe doubled the cross beams up so they wouldn't be as weak as they were. And I learned that building an earthquake-proof building, it's mostly impossible, so yeah. And what I enjoyed about the lab and building is that my mom's an architect, so I got to see what her everyday life is kind of like. And also, it kind of inspired me to, be a builder or a worksman or an architect like my mom when I grow up. Here is the last interview that I shot of Michael Chewy answering the same 5 questions that I answered in the video that was right before this page.
My name is Michael Chewy, and I'll be talking about my Shake Table Lab. So our building supported 10 sandbags. Our building fell when we saw the poles flexing, and we're gonna basically chop off because we didn't tape the thing that connected to the structure. Well, I would have done a better job on a better taping job, and I would have also put the structure better so it could have supported the sandbags. If I had another chance to do it, I would put my poles and my cross beams better because I think those were the ones that were shaking, flexing, and were gonna break. So I like this project because I got to see how architectures really work together to make a house that will support an earthquake. And I felt like this is a great project because I got to work elaborately with my partner. I think that building this structure was it was a bit hard because you had to, if your partner wanted this, you either had to follow it or detest it. So yeah.